How you doing, ROS developers? Yes, I'm here back again and ready to do another live class here today and learn a lot about how to make robots navigate. Today, we are going to talk about how to navigate outdoors, how to use a GPS, because maybe you have a robot that it's navigating inside a building. And then for that, have been using on the previous live classes, we have been using the laser, the odometry, and all that information, and that's good. But when you go outside of the building, what happens? It's very difficult to create a map in the outside, on the streets or maybe even on the countryside. So for those cases, we can use a GPS. We are going to see today how to configure a robot to work, to navigate by using a GPS. You're going to see it's quite simple. And I hope that you will apply this to your own robots. I will try to explain how to accommodate to your own robots. Okay, and then I can see here that people is starting to get inside the class, and I can see Linda Capito. Hello, Linda. How you doing? Danny Dask, hello. And Kashif again. So all those people, they have been attending to all the previous live classes. I see here Haro Stanko and their Capute, of course. And there is a message from Norio at the beginning of the chat, but I don't know if he is attending here. So Norio has just started to be one of the interns of the construct, and he's doing a very interesting job as an intern because he has to replicate some paper results inside the ROS-DS, so anybody will be able to reproduce those results. So keep posted to our channel, and then you will be able to get this ROS-jet that is going to be very interesting because we are going to use reinforcement learning and some OpenAI libraries. But anyways, here more people is coming. Here, Stilianos, hello. Mertz, hi. Mechatronica Maxima, super cool nickname, Mechatronica Maxima. And I think it's time that we can start. Hello, Wa, also last in the line to say hello. And then let's go, let's start. So every one of you already know, for the newcomers that sometimes appear here on the live classes, how does it work? We are going to learn about a very specific subject of ROS, okay? It's how to navigate with GPS today. And for that, I have prepared a ROS-jet. A ROS-jet is a ROS project that contains notebooks with instructions, detailed instructions, code, and simulations. So I'm going to share this with you by using our ROS-jet link just right now on the chat. And then you will get access to that ROS-jet right now. So you have to use it right now. You will click on that link and then you will get a copy of my material. So I'm going to show you my screen and then you will be able to follow the same thing as I am doing, okay? Sorry for the guys that already have been here on the live class for many weeks and you already know how it works, but we need to say hi and, to say to the newcomers to help them a little bit because they are new. So that's understandable, but that's it. Let's go and let me share my screen with you and then you will see how can I share my ROS-jet. So you can apply this also for your own ROS-jet later. So let me see. And first, I'm going to share my screen, okay? So for that is this screen. Now you should be watching my screen. Okay, so I'm inside the ROS-jet already, but let me go to my list of ROS-jets. So I'm inside the ROS Development Studio. And it's this address here, rosdsdeconstruction.com. And here I have the ROS-jet that I have prepared for this live class today. It's live class number 52. I'm going to share with you the ROS-jet by copying this link and pasting it into the chat. And now I realize that I don't have the chat here. Let me go back here. So I have to go to the chat, just a second, because today we are doing something different. That is, I have two computers. So one of those is the one that has the chat, just to be able to watch your questions in real time. Okay, so I can see the questions in real time, and then I will be attentive in case that you have any doubt, any question. You can put it on the chat beside the video, and then I will try to answer as soon as possible in order to make this a little bit more dynamic. So here it is. I'm on the chat. I'm sharing with you. You should see now the link that contains the ROS jet that I have shown with you. I have shown you here. So if you click on that link, you will get a copy of this ROS jet. Okay, so I think it's quite clear, quite simple. Just click there on that link, and then automatically the whole process is automatic. You don't have to do anything. Once you have the link, then press this button, select the ROS jet, then press this button that says Open ROS jet. Let's go, and then it's going to start the ROS jet, and well, then initialize the files and do whatever it has to do. And I was doing all this, so in the meantime, let me just, yeah. So this is something that happened also last time, and it shouldn't happen. So it should open quite fast in that case, but maybe there is something in the latest release that we have done. So I have to check afterwards. Don't worry. So it's going to open. In the meantime, so what we are opening here is called a ROS jet, okay? And a ROS jet is a ROS project that contains, as I mentioned, notebooks. It contains can contain simulations and code. And what is interesting about that is that you can share as simple as this. So imagine that you are preparing, for example, a class for your students, or that you are doing a paper research, doing experiments as Norio is doing for the construct. Then you can share your results with somebody else, and this other person will be able to execute the same thing in the same situation as you are doing. So they will get the same results as you. Okay, so let me say no, because I want to start from fresh. And when you do that, then the Jupyter notebook with the instructions will automatically appear. I hope that most of you are already on that page. I will wait some seconds. And let me tell you in the meantime that this is a collaboration that we are doing this live class with a company called Robotnik. And those are super cool guys, super professionals. They have a company, they build robots and also sell parts for robots like lidars, other sensors, actuators, and all of them are ROS certified. So whatever you buy in the shop, it's going to work with ROS off the shelf. So I highly recommend you. And we are friends, so we are not getting any money for doing this promotion or something. Is because I like very much their work, and they left us their robot, the real robot. They sent us the real robot to do experiments here and do a live class, etc. So, but anyway, so I was just explaining you about Robotnik because they are very cool guys, and then I wish them the best of lucks. And then what about this class is what I mentioned about doing GPS. GPS is outside the building, so it means outdoors. Sorry, I was looking for the word. Outdoors navigation of the robot. So what we are going to see is how to make a robot navigate in the outdoors. So for example, here you can see that we have prepared a simulation where the Summit XL robot by Robotnik, it's running inside an outdoors environment, and then the robot will have to localize inside here. As you can see, it doesn't have many references, just a few trees. So even if you could create some map of those, that would be quite difficult in case that somebody goes around also there. If there are other people, then the robot can get confused very easily because there are almost no features there. So for that, let's use the GPS because we are outdoors and the GPS signals are there. And this robot already contains a GPS. It also contains a laser, of course, and then a camera and IMU. So let's use all that, yeah? And here you have some extra information about how to use this ROS jet and how to create your own ROS jets in case that you are interested in the ROS Development Studio. So this is not only a tool for following the class, the live class, but also is a tool that you can use for your own ROS projects. Okay, let's start. Let's start launching the simulation. Okay, first we have to have the robot. So for that, we need to launch the simulation. And in this case, I have kind of prepare a simulation. Okay, so I have been using some other files that are already installed there in the ROS Development Studio in order to create a custom simulation. And the custom files, the launch files of here, you can find them here. If you go to Tools, IDE, then let me put it here and make it this like that. Then if you go to Simulations Workspace here, you will see the material that I have prepared related to the simulation only. Okay, so Simulation Workspace is only for material related to the simulation. So if you go to Source, I have created this is very stupid package. It's called Summit Outdoor World. Very, very stupid, very simple. That only contains a launch file, actually. You know, because I know that in this ROS Development Studio, it's already installed this wall. That this wall was created by ClearPath Robotics. So the wall that you can see here on the outdoors. And also I have the simulation of the Summit Excel that has been created by Robotnik, of course. So what I have done is to create a launch file that combines both of them. It's very, very simple. It's just launch here the scenario of the outdoors environment, and then here load everything related to the Summit Excel, including the control. Okay, so you can have a look afterwards. That's not the subject of this course. Just telling you because you can find it. This is a very instructive thing. Okay, so we have to launch this simulation. How can we launch it? Okay, you can go and do a ROS launch, that you know, but we are trying to make it easier for you. So you go to Simulations and then select Launch File. Today, we are not going to launch one of the pre-configured simulations here, but instead we are going to launch the one that I have created there in the simulation workspace. For that, you need to select Launch File and then go here to this drop-down menu and select the only one that is the launch file that I have created. Press Launch, and then the simulation will pop up. So remember that in this simulation, it's interesting because first, it's an outside simulation. Okay, so it's looking like the countryside, and then also it contains a GPS inside the simulation. So there is a special plugin there in the wall that is generating the GPS simulation data, like if there was a satellite on that simulation. Okay, so our robot that contains a GPS inside it can detect this simulated GPS signal, and then it can use it for localization. So that's super cool, isn't it? That's very cool. And then I can see here that maybe I have done some mistake on the last minute. Yes, but nothing that we cannot solve it. Okay, so I think that I put the robot here beneath the area of the ground. So let me please do this with me. I'm sorry for that. Is just move this the ground a little bit like this until you find the summit that is here, and then you select it and press those arrows here, and then move the robot a little bit up, selecting the blue line. Then once it is up, then you can leave it like that. So I put it too much up, but it's falling, it's slowly falling. Okay, so yes, I don't know why it's going so slow. It should also actually fall faster. But anyway, so it's going to fall here on the ground and stay there. Sorry for that. That's a parameter that is here, and I did it wrong. So It's a parameter that, oh, so finally, yeah, I can see. So finally, I didn't save it. Yes. So here, when you do the spawn, you can add here the coordinates. So you should add here, if you want to, not here, here. At the end of this argument, you can indicate minus Z and then some value. For example, 0.5. So that would spawn the robot 0.5 up in this environment. So that would be better. Okay, nothing important that we cannot solve quickly. Great. So let me see. So there it is. The simulated robot is already on the ground with its wheels on the ground. That's cool. And then Stiliano says, no gravity on that planet. Yes, there is gravity. So I don't know why it did it like that. So I don't remember having disconnected the gravity. So there should be gravity there. But that behavior is very strange. It's very strange. So anyway, don't worry about that. That's not important for our work here today. So let's continue. Then why to use the GPS for navigation? Already explained to you, because we want to localize the robot in the outside the buildings, and then making a map. Even if you can do it, then it's very prone to mislocalize your robot, because there are not many reference points. And but anyway, let me tell you that there is a project, super cool project, that is called AutoWare. If you don't know this project, that is AutoWare, let me show you here. It's very cool because they have created an open source software for doing autonomous cars. And actually they are creating maps of the cities using the laser. So you can download the code from them, and well, that's the official page. But if you go to autoware.org, I think that's one, then here you can get the code and download and use it in your own computer, or even try to put it on the ROS.ds. Actually, it's supported on the ROS.ds, but still. So here we have Start AutoWare, but it's still under process. So, well, anyway, let's go. Then we are going to use the GPS. Yeah, so then why, if you are going to use the GPS, why do we need to use the odometry or the IMU? Because you mentioned there that we are going to use that. Well, mainly for two reasons. The first one is that the GPS is very imprecise. So it has a lot of error. And then in that case, we can help that with the odometry data. And in order to define quite precisely where the robot is. And another thing is that the GPS is not giving you the orientation of the robot. So it says you are here, but it's not saying which direction the robot is facing. Okay, so for that we need a compass, and then the IMU is the one that provides a compass. Okay, and then it's providing the orientation based on the magnetic field on the north of the Earth. Then, so what are we going to do? How are we going to localize the robot? Well, we are going to use the same package that we used last live class. It's called the robot localization package. You already know, yes? And then I can see here that there is a question from Mert that I missed that say, could you begin this tutorial from zero? Not now, but you can afterwards start the video. So the video is going to be is being recorded, and it's going to be published after the next minute that we finish this live class. So you can start from zero again. Okay, so then coming back to here, so we are going to use the robot localization package. And on the previous live class, we used that package to fuse IMU and wheel encoders data, odometry, okay, in order to provide a better odometry. Now, what we are going to use, this too here in this project, in this live class, but also what we are going to do is to use another part of that package, that is the NAV-SAT transfer node. That this is a very useful package. Those guys, they have nailed it with the robot localization. I love this package. And they have included this NavSat transform node that what it does is to convert GPS data that is provided in latitude and altitude. It converts that into an odometry data, because I mean we cannot understand here in ROS navigation, we cannot understand data as latitude and altitude. How do we make this? So if I want to send my robot here, how do I provide the altitude and latitude of that? I don't know how to do that. It's quite complex. So I need to have a kind of transform between latitude and altitude and 2D coordinates. That it is what we understand. Remember, on the map, we have 2D coordinates, X and Y, and we want to send the robot to those coordinates. That's why we need to do that. And then we are going to use the NavSat transform node. Okay, so far so good. Remember that if you have any question, put it on the chat beside the video. Okay. Then, so what are we going to do? First is to launch the map server with an empty map. Okay, so that's maybe it should ring some bells on some emergency alarms in your head. What does it mean? But for what do we need a map? You said no, we are not going to use a map. Why? Ricardo, explain us. Okay. Wait. Let me drink a little bit of coffee. Okay, so I'm going to explain you. The thing is that we are going to use the ROS navigation stack to navigate, even if we are working with a GPS. So the ROS navigation stack needs to have a map, otherwise, because it's made like this in that purpose. So this is a kind of hack of the ROS navigation stack. We provide an empty map, because if we don't provide a map, then the ROS navigation stack cannot work because it needs a map. And it has to be an empty map, because otherwise there will be some stuff around that the robot will not be able to move. Because on the map, it will indicate that there is some obstacles that actually doesn't exist on the outside. Well, we don't know if those obstacles exist there. So what we want is that the obstacles are put by the robot with a laser on an empty map. So that is why we are going to use an empty map, just to hack the ROS navigation stack with a map that cannot make us any harm. Okay, so for doing that, let's create first our GPS navigation package. So this is where we are going to put all our material for making the robot navigate today. So let's create the package. How do we do that? Go to Tools, open a new shell, and then let me put it here. Go to this directory that it's called, actually, ROSCD. No, this is not correct, because ROSCD has been connecting to the terminal. ROSCD is going to give us to Devel. So this command, the next one has to be modified like this, 2 dots / source, like this. Now it's correct. Okay, connect to yeah, come on, connect. What is happening here? Please connect already. And so once I connect, then I'm going to create a package that is going to be called GPS navigation. You know how to do it. Catkin create package. Okay, ROS CD 2 dots source, then catkin create package, and then the name of my package is GPS. Oh, okay, so let me check. I think there are some connection problems here. Okay, ROS CD again, CD. This is because of my internet connection. Catkin create package. Then the name is GPS navigation. Please respect the names of the packages and files. Okay, otherwise the example will not work. Once you know how it works, then you can change the names and do whatever you want. Then what else? So inside the GPS navigation package that we have created here, we are going to create another 2 directories more. So let's go to inside the GPS navigation, and here create a directory that is called maps, and another directory that's called launch. Okay, so the maps is going to be used for storing the map. The launch is for launch files for the different parts in navigation that we are going to launch. And actually, we need another directory that is going to be used later. Let's create it right now. It's easier. So it's called config. So create another directory that is called config. Remember that you have to be doing the same things as I am doing here. Please, this is the most important part, that you are practicing with me and you are doing it. And then when something doesn't work for you, just tell it me on the chat, okay? So I want you to learn. I want you. And in order to learn ROS, you have to do it. If you don't do it, if you're just watching the video or listening, or it's not going to work. So please do it and let me know your doubts. I will do my best to answer you. So we have those directories, and now we are going to put the map inside the maps. Okay, so in theory, you should create now an empty map and do it. I have already done it for you because, I mean, it makes no sense that we waste our time here. And then for a map, as you know from the previous live classes, a map in ROS, it's defined by 2 files. First one is the graphical file that contains the graphic of the map. And that I have included here. If you go to the IDE, here you can see that it's called mymap_empty.pgm. It's a map in PGM format. So that is the map. Then what we are going to do is to open the Catkin workspace where I have my package, then go to source, then GPS navigation, then go to maps, and then it's empty. Okay, there is nothing. So the first thing that we are going to do is to put that file, move it from the current location to the maps directory. Okay, so drag and then move it there to maps. There it is. Yeah, sometimes this IDE sometimes doesn't refresh itself. If it doesn't show your file here, don't worry, it is there. You can just close the directory and then open again, and then it will show. For example, in this case, it has remained the file there. So if I come here and I close it and then open it, then it's not there anymore. Yeah, something that we are looking to solve. Don't worry, nothing important. Okay, so we have one of the map files. This one this is an empty map. It's actually a white space without any obstacle and very big. Now we have to create the YAM file, the other second file for the map. And okay, so you should understand how that works, etc. But I provided already all the information here because this is not the subject of today, how this map info is related to this PGM file. So this is very simple. It's basically where is the origin, what is which color we consider as a copy, the resolution, and the name of the PGM file. That's very simple. So let's go and here on the maps directory, let's create a file. Let me move it a little bit. Okay. Then here, create another file. So right click, then say new file. And then you have to call it like it is mentioned here on the notebook. So it's mymap_empty.yam. Okay, so that's it. That's empty. And then you have to put the content of this file in there. This is not usually required when you are using normally the ROS navigation stack and you are creating your own map, because all those files are generated by the map server itself. But in this case, we are hacking the map server. So that is why we have to create this manually. Okay, so you can use this for your own GPS projects, the same files. Okay, we got it. So we got the map, the empty map there. As you can see, the file here is not shown, but I'm going to open it and then there it is. Okay, so I have my maps. Now we are going to create a launch file that is going to start the map server with that empty map. Okay, so easy. It's go to the launch directory in the same GPS navigation package, create a new file. And it's going to be called like start underscore map underscore server dot launch. Please respect the names again, because otherwise something is not going to work for you. And the content is this one. So it's, let me copy and paste, and you are going to see that it's very simple. Here. Okay, so far so good. Then what it does is says, hey, we are going to launch the map server as a map server. Okay, so as a map server, so is the package map server, and the binary is the map server. And we are going to use as a map the arc map file. And then we are setting this map file here. Here is the map file. And where is it? Well, it is this line. It is on our GPS navigation directory, maps, my map, empty, yeah, that's it. So we are loading what we have just created here, that is going to load by default afterwards the PGM file. Okay, so far so good. So we have the first step. Second step, then we need to convert the GPS data into odometry data, what I mentioned before. So the GPS data, if you go to a shell, a terminal, here, let's see a ROS topic list. Let's do a ROS topic list. Then there is a topic here that it's providing the GPS data. That is, let me see, where is it? It's a GPS fix. Okay, so the GPS fix, it's providing the GPS data. But if you do a ROS topic echo minus N1, just to want to see one message, okay, GPS fix, then you're going to see that the data is local latitude and longitude and altitude. And okay, we don't care about the altitude, but anyway, this is nothing related to a 2D map like we have in navigation, in robot navigation. Because of that, we need to convert. And for that, we are going to use the NavSat transform node that is provided inside the robot localization package. Okay, so let's create this robot localization package is a package that is installed inside the ROS Development Studio and that you can install inside your robot, your real robot, or inside your local computer, whatever. It's a ROS package that is installed. Okay, so the only thing that we need to do in order to launch it is to configure it in the launch file. So let's do it. Let's create here in our launch file directory of GPS navigation. Let's create here another file that is going to be called start NavSat. Start NavSat dot launch. And what is going to contain? The code that is here. This is the key information. So let's first copy it and let me explain it later. Okay, so copy everything and paste it on your new launch file. Great. Then what are those things? Well, basically what we are indicating here is just, from the package robot localization, launch me the NavSat transform node. Okay, and then with those parameters here, those are the parameters that this node needs to be configured in order to work. And those are the ones that you will have to set up for your own robot. I have included here a description of each one of those, so you can check it later, better, but let me go one by one, okay? So, well, first of all, before going to the parameters, let me go to the most important ones that are the topics that have this package. The NavSat transform node has to connect to the source of data, okay? So for that, it's going to use the IMU data, then it's going to use the GPS, and it's going to use the odometry. So in those remaps here, you should indicate here, in this second part, you should indicate here the name of the topics in your own robot. So in this case, for example, in our robot, the one that we have now here, the IMU data is provided in a topic that is called IMU data. Then you have to put it here. Then the GPS data is also provided in a GPS fixed topic. So we have to put it here. Then the odometry is provided here in a topic that is called odom. That is why we put it there. Okay, so those are the names of the topics that the NAVSAT transform node is expecting. And here you have to indicate which one is the actual one in your robot. Yeah, so this is what the program, the NAVSAT, is expecting as a name for the topic. And then this is what actually is on the robot. So for those two cases, we have that they are the same. So that's great. But for the odometry, it's not. It's different name. So that's why we change it here, because the program is expecting this name here, and the actual robot is providing the odom. Yeah, I hope that this is not very confusing here. I know that for the people that already knows a lot about ROS, then this is not a problem, but I understand that for the new people, this concept is a little bit confusing. So that's why I dedicated some time to explain you. Okay, so those are the most important ones, because it's the information that the Kalman filter is going to use to integrate everything and do the conversion. So that is the most important part. Then we have all these bunch of parameters there that allow you to configure for different configuration, different types of GPS, etc. For example, this is magnetic declination gradients. Okay, so this is a parameter that you can set. We set to 0 here because in our case it's perfect. Basically, this parameter, what it does is measuring the difference between the magnetic north and the true north. So if your GPS is based on magnetic declination and magnetic orientation, is detecting the magnetic orientation, then you will have to provide here the difference between those two. And here I have included here a link where you can configure and calculate this for your own location. Then we have the yaw offset, and this is the value that you have to indicate if there is a yaw value in your IMU when you are facing the east. So in theory, it has to be, when you are facing the east, the yaw value should be 0. In case that it doesn't, because you measure, that's an offset that you have to include here in this parameter. How to do that? So that's a lot of work, because you have to measure, read the values, and then, well, that's a pain. That's a pain. If that is your case, okay, so good luck, because you are going to have some work. Then 0 altitude, okay, so then it's just if you indicate 0, then it means that the Z is going to be published as a 0 always, because we don't care here. We said, okay, 0 altitude, so true. Then broadcast UTM transform. This means that the UTM is a frame in which the GPS the GPS data is being generated. Then if you set this to true, you can generate a transfer between the UTM and the map frame. So you will have a conversion between UTM and map done by the TF. That is quite useful in some situations, like making algorithms, for example, for the robot to autonomous move around following a set of points. So that is quite interesting. Then publish filter GPS. It means that if you set to true, then the system will publish in this topic a GPS with orientation, and with orientation, and also with with orientation, with improved odometry. So it's taking into account the odometry and the IMU in order to improve the precision of the GPS data that is being obtained from the GPS itself. So you will get a better GPS value here. And then use odometry, that was okay, yeah. So okay. So in this case, is to use the yaw of the odometry as a yaw value instead of using the IMU. So in case that you have a very precise odometry system, then you can set it to true. And that one is waiting for datum is for setting the zero of where is the origin of the GPS. So you can use that and set a transform between map and base link that is setting the zero of your GPS. And I have included here that in case that you need it. In our case, our zero of the GPS is a zero of the map. So we are not publishing this. Okay, so far so good. Then let's go, and we have created the NavSat transform. So we have now an odometry value that is being published by this guy, that is odometry filtered, it's called. And then now let's start our localization system that is based on that data of that odometry that has been generated from the GPS signal. And so what are we going to do? How do we do that? Well, we are going to use again the robot localization package. And we are going to generate a second instance of the robot localization package. This time is going to use the EKF localization node to localize the robot. So what he's going to do is he's going to get as an input the GPS odometry that this node is generating. So he's going to take that. He's going to take also the odometry, normal odometry of the robot. He's going to take also as an input the IMU of the robot. And then he's going to generate a localization of the robot. That's exactly what we did on the last class. So you remember. So in the last class, we only did that. So, but it was only to generate an odometry value. But now in this class, we are using this in combination with the GPS signal. So that is going to provide us with a global localization position. So it's actually telling us where in the map is the robot, because we are combining the GPS with the local odometry. So I'm not going to say to indicate how to configure this AKF localization launch, because we already did it on the previous live class. So I'm going to show you just how to create a launch file here to launch it. And also I'm providing here the GPS localization config file. I am providing this here, and we can have a very quick look now. So what do we do? Let's launch the localization node. So we have, let me recap, too many things here. First thing is we have created the launch file for the map server. Okay, so that's the first launch file. Then we have created the launch file to convert GPS data into odometry data. Third, we are going to create the launch file that uses this GPS odometry data into actual localization of the robot in the map. Okay, so that's the launch file that we are going to create now. So let's go again to the IDE, and here in the launch directory. Okay, wait here. So create another file that is going to be called created badly. Okay, new file that is going to be called EKF localization, EKF underscore localization dot launch. And then inside there, copy the code here. Okay, so copy and paste here, and let me show you what it does. Basically, you already know, basically, it's launching the node that is the robot localization package and the EKF localization node. That's it. You know that this is for producing a better localization of the robot. And then how do we configure this? As you know from the previous live class, we need a YAM file that contains all the configuration parameters. And where is this config file? Well, it has to be inside the GPS navigation package. That's our package. Then inside the config directory, okay, we got the config directory we created here. And then this file, GPS localization config YAM. I have included that one here, okay, so we don't have to create it again. And just select that one and put it inside the config. Oh, sorry. Wait. What did I do here? So select that one and then put it inside the config directory. There it is. Okay, so, and then as you know, this one is the config file that I had so much trouble the previous week on because I missed the commas here. And so now this one has been tested, so it's going to work. And here, have a look at here, because we are adding 3 things. First one is the odometry, normal, as in the previous live class. We want to mix this is the odometry generated by the robot itself. Then the IMU data, that this is the IMU data that is generated by the IMU that is inside the robot. And then here we have the odometry GPS. This is the odometry that is being generated by the GPS data. Okay, so we are mixing all those, and we are getting a better localization. And you can watch this as a black box that works. Okay, just in case that you need more information, we have a course that we explain in more detail beneath this notebook, so you can learn more about that. Or you can check also our previous live class. Okay, so we got it there. Then now it only remains that we launch the whole navigation system based on GPS. So we have to launch all those things at the same time. And before that, let me check, because there is a question here. And then Lawrence said, hey guys. Hello, Lawrence. I don't know if you wanted to ask something or just say hey, hi. So, hey, Lawrence. Then Sayantan says, sorry, I joined late. Where can I get access to the Jupyter notebook you are referring to? There is a link here on the chat. You can see that it's called rosjet.io. And you click there, then you will get the access. Great. So now we are about to launch everything. So how does it work? We have to create another launch file. And then inside this launch file, we are going to include all the other launch files that we have been created. So we are going to create one for launching the NavSat. We are going to launch another one for this localization package that is going to produce the localization of the robot. And we are going to, of course, we have to run the map server that will contain the map. And finally, I have included this one that is the move base. Do you remember the move base? So we have been working with navigation on the last 4 weeks. And there was one that is the move base. The move base is the one that produces the paths and the obstacle avoidance behaviors. So you know from previous live classes, I think it was on live class number 50 that we explained about this, and we created our move base. So for your convenience, I have included here it's a package. It's called the My Move Base that is here. Okay, so this is what we did on the live class number 50. I have included here in order to use it for making the robot being able to move from one side to other, create path, and avoid the obstacles. Okay, so I hope that this is clear. Those are all the parts that you need, the basic parts for doing GPS navigation. Okay, let's create that launch file. I want to move that robot using the GPS. So let's go here, launch, and then create another launch new file. And I don't remember how did I call it. It's called a start GPS nav. Okay, start underscore GPS nav dot launch. And inside there, you create this. So I have already explained, okay? So I suppose that you understand what we are doing here. I don't want too much this copy paste. It's just for going fast, but I like to explain what we are actually copying. So in theory, there should be no copy paste because it's not a very good idea, but based on the time that we have, that's the best that we can do. And let's go. So we got it. We got it. So we have first the simulation running that is contains a robot with the topics, and also there is a GPS on that simulation. And I don't mean the sensor GPS in the robot, that it is, but I mean there is a GPS in the world that we cannot see, of course. So it's there, but it's generating the data. And this GPS here is capturing that and sending and publishing the data on a topic. That is the GPS fix that we already saw. Okay, so now we are ready to launch. So we go to a shell and then we launch our launch file. The one that we just created, that is the one that is going to launch everything. So go ahead, launch it. Navigation, GPS navigation, then start GPS. Nav launch. Okay, so there we go. Let's hope that there is no error. Yes, I always doing a lot of errors. Mr. Toxic says that he needs a help. Okay, so I'm here, Mr. Toxic. Tell me, how can I help you? I'm drinking cold coffee. Already it's cold. Yeah. Okay, in the meantime that we wait for the question of Mr. Toxic, we have here the everything run and no problems now. Yeah, great. Wait for me. We are going to see if that is correct or not. So Mr. Toxic says, I'm unable to subscribe for a monthly course pack. Okay, so sorry, Mr. Toxic. I will talk about that later, okay, once we finish. Don't worry, I will answer your question, but now we have to continue with the live class. I will answer you. Okay, Danny Das also reports it's working flawlessly. Yes, so we recovered from the disastrous live class of last week. Very good, but now is the most interesting part, is we need to see that on Arbis and send some goals to the robot and see how it moves around, if it is true that it's been localized. So let's go to tools and open a new shell. And then let's launch the Arbis, the Arbis tool, yes? So let's launch the Arbis, and then once you have launched the Arbis, you can load config file that I have prepared for watching everything on Arbis. So there is a launch config file. Let me simplify this a little bit. So here you can see that there is a GPS config Arbis. So you can use that one. Wait a second here. Oh, okay, yeah. So you can use that one to configure your Arbis, and you will see then is everything configured. So you can see the empty map, you can see the obstacles detected by the laser, you can see the robot, and we'll see the paths. And I'm having some problems here with my terminals today, but I don't know. Mr. Toxic says, it says my card is not supported, although I have an international card. So sorry, yeah, Mr. Toxic, I'm going to go with you on that problem. Don't worry. So don't worry. Let's now finish the live class, because we are about to finish and we want to see if everything is working. And I will promise that I will solve this problem with you. So now let's launch the Arbis, cross-run Arbis. And as you probably know, this is launching the Arbis, but Arbis is a new window. And because this is a web environment, so it cannot spawn new windows on the web environment. For that, we have created something that is called the graphical tools. So let's go to the graphical tools to see the window of the Arbis. So for that is go to tools, then graphical tools here. And if we open it, then it should show here the Arbis. Great. So let me put it bigger. And here on file, let's open the config file that I have prepared for you. So go to file, open config here. it's not in this directory. We need to go one up. And here it is, GPS config RBS. Select that one. And then everything should appear properly. Yes, 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 we are getting there. Okay, very good. So here you can see that there is an empty map. Here there is nothing. Here are some obstacles that are detected by the robot. And now we can use this for sending navigation goals. And then the robot will actually move to the correct location. So let me put it a little bit here, better. And here, no, not that one. I'm going to minimize that. Then put this one here and put also the simulation here, because by doing this, we can see. Okay, so you can see that the robot is there, is detecting some of the trees. And now let's, for example, let's tell the robot to go to one place around here. How do we do? You select here a navigation goal. Here, navigation goal, click on it, and then go to a location, and then say click without releasing, and then indicate the direction that you want the robot to face when it has reached the location. Okay, so for example, reaching here. So now you can see that the robot has generated one path, and it's avoiding the obstacles, the trees. And here you can see that the robot is moving around the trees and going to the location that I have indicated. Okay, so it's working using the navigation system. So then there is another question here by Sohin. Hello, Sohin, nice to see you around here. So then it says, sorry, means the map server part. Is the system using an empty map at the beginning? Yes, that is right. It is in an empty map, as you can see here. There is no map. Okay, so the robot is there, and then it looks like it's using the localization properly of the GPS. One of the things that you can do in order to test if that is right, it's quite funny. So you can try to perturb this robot. So select the robot and then move it on one location somewhere. And so you change the location of the robot. And then once you hit that button here, the new location will be set. So that is still not set. And then you have to see here in the localization system that the GPS-based localization has detected that the robot is in another location. Then it has to put the robot from here into the other location that corresponds to this location here. So let me hit the button. There it is, and there it is. Then it appears beside the tree, and also with the proper orientation. Yeah, okay, so it's working, guys. It's working. So I hope that you enjoyed this live class, and that's all for today. That's all for today. So if you like the live class, please give us a thumbs up. I see that there is a thumbs down. That is also okay. If you don't like it, then I will please, if you provide us a thumbs down, I would really request you that you give me a feedback, telling me, hey, why? Because this, I didn't like that, or I think that that was like this, or very bad in here, because we want to improve, okay? We want to provide better live classes. Then also subscribe to our channel. We are publishing one new video every day, teaching you about different things. So that's a live class, but we have all the videos that are recorded with the projects included, everything. So I recommend you that you subscribe to our channel. Finally, I wanted to tell you about the ROS Developers Conference. That is a conference that we are doing on June, and it's an online conference. It's quite interesting because you don't have to travel. So you will connect in a similar way as we are having this live class. And we have invited other ROS developers from around the world, and they are going to teach you different subjects on 2 days weekend. And the nice thing is that you don't have to travel. So you can just connect from wherever you are, and you will get the ROS jets, the projects of all those super cool guys that they are the cracks of ROS in the world. And have a look. You have here the link for in case that you would like to know more information and and check about subscribing there. So attending the conference, actually, you don't have to subscribe, you have to attend. Then now I'm going to disconnect my screen and see if there is any additional question. Let me see.